Hey, good morning. Wife thought I should have some, Christmas decorations for the show now because it's that time of year. So, yep, there it is. Walmart. Hey, hey, welcome back. It's Monday and there's a big election tomorrow. So there's not going to be a lot of people watching YouTube, I don't think. So I decided I would, on the tools and stuff, we would sort of hold everything back, products, whatever. It was to sort of push it back until after the election is over with. Because at that point, people will hopefully be looking for entertainment and other things to watch besides, the big race. Both of them seem like they claim they worked at McDonald's in one fashion or another, so I thought I'd throw my hat into the ring. And yeah, I worked at McDonald's too a little bit, but that's when I was very young, and I did not actually run the fryers or something like that. I just worked as a third party or outside contractor to do some repairs at McDonald's at one time. Yes, doing some electrical and communication cable line work at the time when they were updating. Anyway, that's a long time ago. One I wanted to cover today, though, was getting into, and we're coming up with it in the future. I've been doing a lot of research on 3D printing with PLA. And the reason is because there are so many different grades of PLA out there, and it got my curiosity up as to not only what's going on and what's offered out there, what's better for what modeling, that sort of thing, but also discovered that there is companies behind companies that make PLA that then put somebody else's name on the box and ship it out. You know what I'm saying. This particular company I'm dealing with right now, they appear to be have a long history of including plastics for extruders, that extrusion manufacturing in the industrial sector, that kind of thing. And they also make a pile of different PLAs for other companies, including themselves, and they have their own little brand name that they're putting out there or something. So we'll be getting into their product coming up soon. And I really, like I said, when I went into this situation looking at PLA, it was like I went down a rabbit hole. It was like, wow, PLA plus, and then now there's companies that are offering various speeds. That was sort of a given when the big, Core XYZ machines came up with hyper speeds and things. It was like, well, you'll have to buy a PLA that, works with that machine or something. And I was looking at some PLA that was rated up to 500 millimeter a second squared, speed. But the thing was, with that kind of speed, it hit me immediately. It was like, that's a great number, and you can say that about your PLA, and, I can trust it. But the problem is, most printers, even my high speed or hyper speed stuff, is not going to be hitting that speed. We're going to be running around, anywhere from around 100 to 300, something like that, average. So one of the things I wanted to look at besides this was there's something going on here that really is kind of disgusting, but this is a rather kind of pricey PLA actually in the scale of cost. But we make this manufacture this for a client, and they have to be straight, and they are. I mean, they are dead straight. There's no bowing, nothing in there. I can flip it over. It's the same thing. I mean, there's no bowing. They're dead straight. These have been in storage actually for I guess a couple months now, and same thing. All four of these laying here right now are just all the same thing. Dead flat, dead straight. And they don't seem to change much. But if you put these out in the sun or something, you'd have a pretzel in no time. But right now, this is what they'll hold. And as long as they're in fairly ambient conditions, even like my garage here, which is still warm and or cold in the winter, they seem to stay, reasonably straight, and there's no problem. They're not warping or doing any weirdness. But I have tried making these out of cheaper PLA, and right off the machine, we sat there, put them on the table, checked them, and they turned into a bow, just warped like that. So I thought, there are different qualities of PLA out there, there's no question. And if you're doing modeling for yourself, that's one thing. But if you are doing modeling where you're starting to get into 3D print farming or something, you really need to have a good source, good supply, and know what you're buying and use it consistently. If it gives you consistent good models that last and things and stay together like this, You need PLA that's not going to warp or get weird on you after only a couple of weeks, couple of months, whatever. You obviously want you know, something that's going to stay together. And of course, a lot of people are going to say, well, use PETG. I have PETG, and I've had various similar issues with PETG, but PETG is better as far as the humidity and the conditions outside, that kind of thing. They're a little bit more UV ray, you know, but I really wanted to stick on PLA. That's what I'm focused on, because it's the most basic filament you can buy for a 3D printer. The FDM printers right now, this is, you know, it's going to be PLA, but there are so many grades, so many prices. It's like, what do you do? So coming up, we're going to be investigating as to, you know, what should you buy? Now, just last week, I know we talked about the very first PLA to buy would be like an easy PLA that would run easily for beginners, newbies, people just starting out on their 3D adventures. And that was what I recommended, was just an easy PLA, which I gave the brand name out at the time, which of course is no relationship or sponsor to me or whatever, but it was just something that I had found was a very easy to go with PLA for newbies or people just starting out. Anyway, this like this one here is a bit advanced PLA, and I've got all different brand names in over the years, including King Rune, Bamboo Lab, Creality. They all have their in-house PLAs, you know. And then of course there's brand names like the Hatchbox that we talked about, stuff like that. So what I discovered was there's also a lot of different, oh, there's my phone. There's a lot of different PLAs out there, and some of them have interesting characteristics, and that's part of what I want to get into in the coming weeks. But also, of course, we have a huge lineup of tools, which we will start, I guess Thursday we'll start on the tools, and a giveaway. We've got a giveaway here. It's in a big box, and we'll have some more giveaway right after that too, but yeah, we got to get to that. Yeah, one of the different things that we can look at with PLA is not just the finish and things, and you know, less layer lines or visible layer lines would be nice, you know, but something like this. I took this to a meeting a couple of weeks ago and set it down on a counter, and the boys looked at it, as they say, and they all thought it was aluminum. They were shocked to find out, nope, this is just PLA off of my machine. I had designed these for my lights, and this is what I made, but this was to hold the bar that would mount the lights to it. And this was, like I said, this is a PLA that has a metallic look to it. And it's not great, it's not perfect, but it, like, at a distance, you know, from a few feet away, you'd swear you're looking at a nice polished piece of aluminum or something. So it was like, that's a win for me. But it's not just that, it's the quality and the speeds and what kind of temperatures you can run with the PLA. And there are some differences out there. Yeah, you know, it's like, wow. So we're going to try to get into all that down the road. Now, the other thing I was going to get into, and I wanted to explain this because I talked about it last week, we wanted to take a piece of software, and in this case we were looking specifically at plasticity. It's a $150 piece of software. Well, we're going to buy it, bring it into the computer, show it to you, design something basic, you know, like this kind of idea, and go through all the steps and the sketch and the slicer, you know, and then bring it to the machine, make it, and then take a look at the model and see how good a model can we make from software such as, in this case, the big question, you know, plasticity, because I haven't seen anything that's really well documented or detailed about modeling from plasticity to what you get off a 3D printer. There has been some sort of short ones, but nothing really concrete that makes me believe in that software. So I thought we would do a show about that. Well, turns out we didn't get it yet, so yeah. So we'll be working on that in the future as soon as I possibly can. I want to get to that because I want to take you through all the steps of, you know, installing the software, running the software, to creating something, a shape. It'll be a fairly basic one with some holes in it, this sort of thing, you know, and then going to the slicer and setting that up for good quality or something, put it on one of our, you know, hyper-speed machines and print it, and then take a good look at the model itself. And this is what we drew. You know, how did it come out? You know, is it look as good as it should from other slicers, other software, you know, like Fusion 360, something like that. Yeah. Oh, thank you so much for watching Coffee and Tools. Please like, share, and subscribe, ring the notice bell. We're not doing much today. Over and out.